Hey everyone, in this video we are going to talk about breadboards. A quick disclaimer, they are not edible. So, what are they and how can we use them to prototype our electronic circuits? Well, simply put, a breadboard is a device, or thing, whatever you want to call it, allows you to build and test electronic circuits without the need for soldering. Let's take a closer look at how the breadboard works. The breadboard consists of rows and columns of metal strips. So, unless you have X-ray vision, you cannot see the metal strips. But who needs X-ray vision when you got me? Well, this is what it looks like in the inside. With this type of breadboard, we have 4 main rows labeled power rail A, power rail B, and 2 in the inside, row A and row B. In the power rails, we have 2 metal strips running parallel to each other. One is the ground and the other is positive. Just note that power rail A and B are not connected to each other, which means we can run rail A with 5 volts and rail B with 3.3 volts or 12 volts. On to the other 2 rows. Row A here is divided into multiple columns, which are individual metal strips labeled 1 to 21. Same goes for row B. On the actual breadboard, we have 63 individual metal strips, and that is 63 on row A and 63 on row B, giving us a combined total of 126 metal strips. Just remember, these metal strips or columns are not connected to each other. If we zoom in on one column here, you'll notice it's labeled A to E on row A and F to J on row B. These letters are just here to guide you on which hole you connect your wire or component. The point that I want you to get here is that A to E are all on one column and F to J are on another column. This means E and F are not connected. As a matter of fact, you can cut the breadboard along this groove and still have a fully functional breadboard. No, I will not be cutting my breadboard, but if you happen to cut yours, do share the pictures. However, the groove is there for a reason that I will reveal shortly. So, without further ado, let's dive into the demo. Alright, now that we know how the breadboard works, let's talk about how you can use it. To start, you'll need to gather your electronic components. Here, we have some 220 ohm resistors and 3 LEDs. You will also need jumper wires, which are just normal wires with pre-attached pins that fit into the holes on the breadboard, like this. You can also make your own jumper wires like these ones, which can take whatever shape you want. In short, you can use any wire so long as it fits into the holes. Remember not to use wires that are too thick to avoid damaging the holes. Well, you have this single LED and you want to light the hell out of it for some unknown reason. To do that, get your 220 ohm resistor, to avoid burning out your LED of course, and 2 jumper wires. Looking at the LED, we have one leg longer than the other. The longer leg is the positive and the shorter one is ground. We will be connecting the LEDs across the groove. The positive pin will go on the first column of this row, and the ground pin will go on the first column of the other row. The resistor can be connected on either pins of the LEDs. In this case, we'll use the ground side. One of the resistor pins should go on the same column as the ground pin of the LED, and the other one will go into a separate column. This red jumper wire will be our 5 volt supply for the LED, and this black one will be our ground. We'll be using an Arduino to power the LED. No programming is required, just the power output pins right here. We have 3.3 volts, 5 volts, and 2 grounds. Let's use the 5 volts and one of the grounds. Using the conventional flow of current, our current will flow from this red wire into the column connected to the positive pin of the LED. It doesn't matter which hole you use, so long as the holes are all in the same column as the positive pin of the LED. Now the current will go through the LED and out into this column, which then connects to the resistor, and then through the resistor and out into this column, which connects to ground. So, by connecting ground to this column, the LED should light up. There we go. Now, let's add a yellow LED using the same configuration as the red one. For power, we can borrow the 5 volts and ground from the red LED. This yellow wire will carry the 5 volts to the yellow LED positive pin. And this blue one will carry the ground, which completes the circuit. There is another way you can make these connections, which is actually the most common. This is where the breadboard comes in handy. Let's reconfigure our circuit to use the power rails. It is as simple as connecting the positive wire to the positive rail and the negative to the negative rail. Now, whenever you need power, you just tap into the power rail. If you wish to power the rail on the other side, just jump the power with the jumper wires. Now I get why they are called jumper wires. Anyway, connect the positive to positive and ground to ground. Easy, right? Assuming you now understand the breadboard, you can now reconfigure the entire circuit to your liking, like this, or like this. You can actually ground the resistor directly without using jumper wires, like this. Now, what is the groove for? Well, it helps when it comes to connecting to ICs. No, not that ICs. I meant ICs, integrated circuits, like this 555 timer right here. And just plug it in, there, and you can start making your connections. And that is the breadboard explained. Hope this video was helpful. If so, leave a like and subscribe. Do leave a comment down below. We greatly appreciate feedback. Thanks for watching and happy prototyping.